Stop routing your Azure traffic directly between subnets. I just helped a financial services company catch a data exfiltration attempt that would have gone completely undetected, and it only took them 15 minutes to set up the solution I'm about to show you.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm Alex, and I'm here with our resident cloud architect ready to dive into some Azure networking magic today.
Thanks, Alex. Today we're tackling something that sounds intimidating but is actually straightforward once you understand it: service chaining with Network Virtual Appliances. By the end of this episode, you'll know exactly how to force all your traffic through a security inspection point.
Okay, so I've got a basic Azure setup with a few subnets, and traffic just flows between them automatically. Why would I want to complicate that?
Here's the problem. By default, Azure routes traffic between subnets in the same virtual network directly. Subnet A talks to subnet B with zero inspection. That means if someone compromises a VM in your web tier, they can start probing your database tier, and you'd never see it happening. No logs, no alerts, nothing.
That's terrifying. So how do we fix it?
We insert a checkpoint. Think of it like airport security. Right now, your traffic is walking straight from the parking garage to the gate. We're going to force everyone through the TSA screening area first. In Azure terms, that screening area is a Network Virtual Appliance, or NVA. This could be a Palo Alto firewall, a Fortinet FortiGate, or even a Linux VM running open source tools like Suricata for intrusion detection.
So the NVA sits in the middle and inspects everything. But how do we actually force traffic to go through it instead of taking the direct route?
This is where user-defined routes come in, or UDRs. You create a route table, associate it with your source subnet, and tell Azure, any traffic heading to destination X should go to my NVA's private IP address first. Let me give you a concrete example. Say your web subnet is 10.1.1.0 out of 24, your database subnet is 10.1.2.0 out of 24, and your NVA sits at 10.1.3.4. You'd create a route that says, for destination 10.1.2.0 out of 24, set the next hop type to virtual appliance, and the next hop address to 10.1.3.4.
Wait, so I'm basically overriding Azure's automatic routing with my own custom route that points to the firewall?
Exactly right. Azure's system routes have a default priority, but UDRs override them. You're telling Azure to ignore its instinct to route directly and instead send packets to your inspection point. Now here's the critical part that trips people up. Your NVA needs IP forwarding enabled at two levels. First, in the Azure portal on the NVA's network interface, you toggle Enable IP forwarding to Yes. Second, inside the VM's operating system, you enable IP forwarding. On Linux, that's setting net.ipv4.ip_forward equals 1 in sysctl. Miss either one, and your packets hit the NVA and die there.
Oh, so the NVA receives the packet, inspects it, and then forwards it to the actual destination. Without IP forwarding enabled, it would just drop packets that aren't addressed to itself.
Precisely. The NVA is acting as a router, not a destination. It receives packets destined for 10.1.2.0 out of 24, inspects them, makes a permit or deny decision, and if permitted, forwards them onward. Now let's validate our airport analogy. It holds up pretty well. TSA doesn't keep you at security forever. They inspect and forward you to your gate. Same with the NVA. But here's where the analogy breaks down. Unlike TSA, your NVA can also modify packets, do network address translation, or even redirect traffic to a honeypot. It's more powerful than a simple checkpoint.
This is making sense. What are the big mistakes people make when setting this up?
Mistake number 1. Forgetting the return path. You route traffic from web to database through the NVA, but you forget to create a route table for the database subnet pointing back through the NVA. Now your outbound packets get inspected, but responses take the direct route. Your firewall sees half a conversation and starts dropping packets as invalid. Always configure both directions.
Asymmetric routing. That would be a nightmare to troubleshoot.
Exactly. Mistake number 2. Not accounting for NVA failure. If your single NVA goes down, all traffic stops. In production, you need at least 2 NVAs behind an Azure internal load balancer. The load balancer's private IP becomes your next hop address instead of a single VM's IP. Azure's documentation specifically recommends this pattern in their hub-spoke network topology reference architecture.
Let me make sure I've got this. I deploy an NVA, which is basically a firewall VM. I enable IP forwarding on its network interface and inside the OS. I create user-defined routes on my source subnets pointing traffic to the NVA's IP. And I make sure to handle both directions plus high availability.
Perfect summary. And here's your pro tip. Start with a simple 2-subnet test environment. Deploy a basic Linux NVA running TCP dump, create your UDRs, and watch the packets flow through. Once you see it working, you'll understand the pattern intuitively, and then you can swap in a production-grade firewall appliance.
This actually seems manageable now. I was intimidated by the term service chaining, but it's really just controlled routing through an inspection point.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone building secure Azure networks. This stuff matters.
Thanks for watching the Network Ninja Cloudcast. Go build something secure, and we'll see you in the next one.